Hi. Today we're going to actually go over two particular things, but we're going to go into, I would say a majority of this will actually go into what we call the first foray into text analysis with R. Essentially, I will be going over chapters 2 and 3 of that from the book Text Analysis with R for Students of Literature, and this is written by Matthew Jockers. It's a really Matthew Jockers really gives a pretty good little neat way to going about analyzing literature. And the reason why this is somewhat under linguistics as well, because we're looking at language. But in this particular sense, we're focusing more on literature. But this could actually be applied to any kind of text. But for this video's purpose, we're going to just look at Melville's Moby Dick and Austen's Sense and Sensibility. And there are two ways to load up these novels. I already have the novels in text format, so I'm just going to load like text files. But you can also load them directly from a web page. But we're not going to go into that. So to begin, first you have to set your working directory, which I did. And we need to scan Melville. So we're going to scan Moby Dick. And I'm going to kind of narrate a little bit here, so bear with me. So I'm going to first execute this, create this vector text.v by scanning Melville's novel Moby Dick. Okay, and we find 18,874 items or characters. Okay, this is a good place to mention that the scan function can also load files from the internet. If you have an internet connection, you can enter a URL in place of the file path and load a file directly from the web. Like this, text.v, and then you'll have these two little symbols here. These are actually two symbols. Scan, and then in parentheses the website that goes directly to the text file. And then comma, what equals character in quotation marks, and then comma SCP quotation marks \n. Basically what this is saying is that we are we're dividing up each new line. So for every line, now we've created a mark for that. So we marked them. Okay. If you type text.v, you'll see the contents of the first item in the text.v variable as follows, just like right here. And that's what you should see if you were to do that, which we can do. In fact, I'll do it right here, and we'll see what it shows us. So, well, actually, that gave us everything. It didn't even show the whole thing. But if you see here, it's actually marking each line as a vector, or as an item. That's a lie. It's not even all of them. Okay. Wow, that went. Hold on. And as you can see, it took everything. Okay. Oh, but if we wanted to only see the first item, there we go. Now we won't see everything. There you go. And see, there we go. We see the very first item here, because what it has done is separated each line. Some of these are, it's a little interesting. Now, I'm not going to go into OCR as for optical character recognition. There are some weird things that happen, and there's two different kinds of OCR. There's dirty, and then there's good OCR. The dirty OCR is essentially that a computer got to it, scanned it, and nothing else was really done to it. Good OCR, clean OCR, involves a computer and a person to go through and check it. As you can see here, we're just kind of doing a dirty OCR kind of deal. Okay, so I've showed you what happens if you type this, and we get to see the first, we create a vector text.v, and you get to see the first item. When you use the scan function, you include an argument SCP that told the scan function to separate the file using \n. That \n is a regular expression or meta character representing the new line in a text file. What this means is that when the scan function loads the text, it breaks the text up into chunks according to where it finds new lines in the text. The data inside this new text.v object is indexed. Each line from the original text has its own special container inside the text.v object, and each container is numbered, as so. Since you do not want to analyze the boilerplate, and we'll talk about the boilerplate, you need to determine where the novel begins and ends. As it happens, the main text of the novel begins at line 408 and ends at 18,576. One way to figure this out is to visually inspect the output you saw when you typed the object name text.v, which we did at the R prompt, and hit return. Let's assume that you did not already know about items 408 and 18,576, but that you did know that the first line of the book contained chapter 1, Loomings, and that the last line of the book contained orphan. We could use this information along with R's which function to isolate the main text of the novel. Okay, so we're going to execute both of these. We're going to create two vectors, start.v and end.v. So that's basically now we're setting up, hey, where does this novel begin? Where does it end? Okay, cool. All right, awesome. Now we got to remove the boilerplate. That's what we're going to be going through, the steps. So rather than throwing out the metadata contained in the Project Gutenberg boilerplate, save it to a new variable called metadata.v, and then keep the text of the novel itself in a new variable called novel.lines.v. Okay, so we're going to do that from start to end. There we go. There's at the start point and at the end point. Okay. The first line of code takes lines 1 through 407. Sorry. Hold on. From the text.v variable and puts them into a new variable called meta.v, just as the second line of code takes lines at the end of text.v. And then the third line combines the two, start and end of metadata, using the C or combine function. I like to think of it as concat, but combine. So that's what we're going to do. We're going to run that. We're going to combine now the metadata at both ends, before and after the novel. Okay. The fourth line of the main code block is used to isolate the part of the electronic file that is between the metadata sections. Okay, cool. Now we're going to run this next line. Now this next line, remember we told R where does it start and where does it end pertaining to the novel. So we're actually going to now create this thing called novel.lines.v. The contents of novel.lines.v are spread over 18,169 line items derived from the original decision to delimit the file using the new line character. Sometimes it is important to maintain line breaks. For example, some literary texts are encoded with purposeful line breaks representing the lines in the original print publication of the book, or sometimes the breaks are for lines of poetry. For our purposes here, maintaining the line breaks is not important because we're not dealing with poetry. So you'll get rid of them using the paste function to join and collapse all the lines into one long string. The paste function with the collapse argument provides a way of gluing together a bunch of separate pieces using a glue character that you define as the value for the collapse argument. In this case, you're going to glue together the lines, the pieces, using a blank space character, the glue. And that is right here. So that guy right here is the glue. Okay. So let's run it. First, use the toLower function to convert the entire text to lowercase characters. So we're going to change all capital or uppercase characters to lowercase, and that's going to be kind of important later on. Alright, so now we did that. You have a big blob of Moby Dick in a single lowercase string, and this string includes all the letters, numbers, and marks of punctuation in the novel. For the time being, we'll focus on the words, so you need to extract them out of the full text string and put them into a nice organized list. R provides an aptly named function for splitting text strings, that is structure split. So we're going to run that next, and we're going to create a new vector after running that function. The first argument is the object novel.lower.v that you want to split. And the second argument is capitalized W is a regular expression. And a regular expression is a special string that is used to represent a pattern. In this case, the regular expression will match any non-word character. Because you used structure split, you have a list. And you do not need a list. So we're going to now unlist it. The \uppercase W regular expression that you used to split the string ignored all the punctuation in the file, but then left these little blanks, as if to say, if I had kept the punctuation, it'd be right here. First, you must figure out which items in the vector are not blanks, and for that, you can use the which function. In other words, we are now omitting blanks indicated by the exclamation mark. It turns out that Melville has a fairly big vocabulary. In Moby Dick, Melville uses 16,872 unique words. That's interesting, but let's kick it up another notch. What we really want to know is how often he uses each of his words and which words are his favorites. We may even want to see if Moby Dick abides by Zipf's law regarding the general frequency of words in English. No problem. R's table function can be used to build a contingency table of word types and their corresponding frequencies. So let's go ahead and run that. You can view the first few using moby.freaks.t, and we're only going to look at the first item to the 10th item, so 1 through 10, which is indicated right here. And the entire frequency table can be sorted from frequent words using the sort function. So let's actually go ahead and let's just take a look at that. So I want to type in moby.freaks.t, and then we just want to look at the first items, and let's see what happens here. Okay, cool. So as you can see, you're going to see something kind of weird like this. So if you were to type that in. And what that is showing here is, well, here, we're going to now go with the next line. Okay. And so now you can convert the raw counts, you can convert the raw counts into relative frequency percentages using division and then a little multiplication by 100 to make the resulting numbers easier to read. So far, by looking at the table, it's not that intuitive. But let's take a look and see if this will actually show us something now intuitive. Wow. So now we actually see something. And what this is showing us is the occurrences of all these words. And as we keep going, we can see like the is used 14,175 times. That's a lot of times. So that's this frequency. So yeah, and then same with two. It occurs 4,539 times. Okay. So now, let's actually run this next one. We're going to now see the relative frequencies. Let's just see what it looks like. Okay, so now, as you can see, we're seeing relative frequencies. So here you're seeing raw frequencies. And then we begin seeing relative. So what this means is that the is occurring roughly about 7% of the novel. Whereas we see this about in half, about 3% for of. Now let's take a look at this by plotting it. Okay, so we can actually now visually see this, and it makes it a lot easier. And we're only going to look at the first 10. And so, as you can see, Zipf's law says basically that the second word should occur about half that of the first word, which we see happening here. Now, let's take a look at Austin's Sense and Sensibility. That's going to be a little interesting, actually, because we're going to see some things that we may not necessarily see, in Moby Dick. The other thing is I'm not going to actually explain what each of the line of code does because it's essentially the same stuff we did with Moby Dick. So, first things first, we got to scan it. Okay, we got 10,906 items. Whereas the other one, Moby Dick, had like 18,000 something items. Okay. And I'm going to just run through a lot of this code. Now, the reason why I say this is going to be interesting is let's take a look at the plot. That is really different from what we saw in Moby Dick. In fact, actually, it doesn't even follow Zipf's law. So that's kind of interesting. In fact, two is the most frequent one in Sense and Sensibility. But the other interesting thing is I'm looking at the percentage of occurrence here. We saw that Melville, he used like the roughly 6 to 7% of the time. But then we see here, we don't even see anything near that, only half that. The only occurs roughly half. But two is right there, just a tad bit, probably higher than the, but they're about on par there. So that's kind of interesting and a little different that the highest is roughly about 3.5. We're looking at percentage here of these top 10 words. So this brings us back. This brings us to something else now. Let me get to that part. All right. So here we're going to join the names of the top 10 values in each of the two tables, and then use the unique function to show the 12 word types that occur in the combined name list. So we're going to try this out. I'm going to run this line of code. All right, cool. So this is what we get. So, all right, and essentially, just kind of give you an idea in this exercise here. Previously, you should have noticed right away that the top 10 most frequent words in Sense and Sensibility are not identical to those found in Moby Dick. You will also have seen that the order of words from most to least frequent is different, and that the two novels share 8 of the same words in the top 10. Using the C combination function, join the names of the top 10 values in each of the two tables, and then use the unique function to show the 12 word types that occur in the combined name list. So here's a hint, and the hint about here is like we needed to look up how to use the functions by entering a question mark followed by a function name. We could actually then look up unique if we wanted to know. So if we're really interested, and then so it'll tell us what this is. So unique returns a vector data frame or array like X, but with duplicate elements rows removed. So that's what this is, and we can, just to kind of tell you, if we had to use unique there, that function. Okay. But the next thing that we need to now do is we got to write a line of code that will compute which words from the two top 10 lists that are shared. So essentially here, what we're using is we're using the percentage and an n percentage symbol operator. That is a special matching operator that returns a logical, as in true or false, vector indicating if a match is found for its left upper end and its right upper end. It answers the question, is X found in Y? Using the which function in combination with the percentage and percentage operator, we write a line of code that will compute which words from the two top 10 lists that are shared. So we're going to actually now run that. And this is what we get. So what's really cool about this is, we can actually run this thing and just see out of these top 10 words, what do they have in common. Now, for the next part, we have written a similar line of code to show the words in the top 10 of Sense and Sensibility that are not in the top 10 from Moby Dick. So this one right here, we're going to try next, and something happened here. I'm not sure what happened. Wait a minute. Because see, when you see that right there is a bad omen. Oh, I think I see. It was just extra thrown in. Don't ask me how that got there. But anyways, okay, so we're now going to run this thing, and let's just see what we get. Okay. Okay. So what we see from this is that we should see in Sense and Sensibility, and that from Moby Dick. From Sense and Sensibility, we see her and was. Wow, that's kind of interesting. I would never think was. And then from Moby Dick, that and his. Huh. So, yeah, that's kind of interesting. So these are words that don't co-occur in each of the novels. So that's kind of interesting. So in the top 10 words, all we're doing is we're just comparing the top 10. But apparently, Austen, she doesn't really use her or what, or yeah, she did use her or was quite often. but her and was didn't show up in Moby Dick, part of the top 10, and vice versa for Moby, part of the top 10 that we see common in Moby Dick, that and his did not occur in Sense and Sensibility. That's actually kind of interesting, and what can we really get from that? Well, there's several things actually, but it's interesting that first of all, Austen, we know that she uses her quite often in her top 10, and then we see Melville in his top 10 using his. That's a little interesting, and I'm gonna leave that up to you guys to what you think. What does that mean? The whole point of this, what's nice about it, is when we're analyzing literature, we can actually use these tools to help us in analyzing literature, and that it makes our analyses that we make less subjective and more objective. So I hope you kind of enjoyed this. If you enjoyed it, I'm going to try to create some more videos, and it will lean more towards possibly creating a corpus and looking at tokens and that in literature. Because this whole series will actually be about text analysis for students of literature. So we're still talking about language, but we're only going to be looking at it pertaining to novels. So hopefully this was helpful. If it was, give it a like and visit the website. We have a website, so if you check it out at https://omega.uta.edu/ and then the little curly dash JSS7644 / you'll go to the website, and you can also see the videos being linked over there. So I hope you enjoyed, and we'll create some more part of this series.